Thank you, Caitlin. I am going to give myself a little bit of an introduction. So I'm Rachel Penton. I'm on our education and engagement team. I started in August, and the symposium was my first project. I have been teaching undergrad neuroscience for a decade, first at CSU Channel Islands, so that's California State University Channel Islands, which is Carnegie ranked like M2, so master's granting, really focused on teaching. And then I moved to UNC Chapel Hill in 2018, and then before I came here, I was at the level of teaching associate professor. Okay. I've been teaching with Allen Institute data since 2021. Before that, I was finding other data sets, so I taught with the Fly Connectome in 2019. Before that, there's random images of real neurons all over the internet, and I was baking those into my classes as soon as I had a neuroscience class to teach in January of 2015, the first class I ever taught to undergrads. So I'm really passionate about teaching with open data, and I've been a fangirl of the Allen Institute for a long time, so it's super exciting to work here. So what I want to talk about is what we're trying to do to provide some practical support for undergrad educators to teach with our open science, okay? I want to provide a little bit of context. As Caitlin mentioned, we're now a team of 8, which is fantastic. It grew from just Caitlin. And as Rui did this amazing job this morning, showing you all of our science, right? Which is 3 scientific disciplines plus 1 on the way, and 20 years of work. And then there's 8 of us, and we have several audiences, which is amazing, so happy. But I do want to say this has really informed what I've chosen as a strategy for undergrad ed, because there's few of us that work on it, and we can only do so much, okay? So. Those of us that really focus on doing undergrad ed on the team include myself, Lauren Alfiler, Maddie Mueller, who you met, gave a talk yesterday, who's starting a PhD program in the fall and is dropping to half-time, and Omar Quintero Carmona, who some of y'all may already know. He is an advisor for our team and is actually like a 20% effort employee here that really focuses on one specific faculty development workshop. So, and I want to flag that we also get support from some other members of the team on very specific things. As I mentioned yesterday, if Troy isn't around and doing stuff, nothing gets done on the team at all. So Troy is definitely instrumental here, and Claire works on a specific type of resource for us that I'll call out. So yeah. So I want to talk about our goals and overall strategy for undergrad ed. I want to talk about how that's leading into us providing educator development programs and what that looks like, and then resources we're creating for undergrad education. Okay. So I want to mention that, and you may have noticed as Rui was talking, right, we don't just do open science, we do emerging science, which I think is really important. We're doing techniques that haven't been invented before they get invented here. If they have been invented before, we're now scaling it into a pipeline, okay? So the science looks very different, and it changes how you teach it, and it gives us some really cool opportunities when we teach with our science. I want to call out that this will enable us to inspire curiosity and innovative thinking, right, in our students who may be the next generation of scientists, but may also be our science-informed community members, right? This will help prepare students for uncertain future. If you're already learning the things that are a little uncertain because you're at the front or the edge of the field and not everything is established yet, that better prepares you to deal with uncertainty in the future, right? We can demystify and humanize science for students. When you're looking at open data that is new, you're actually able to see all the really beautiful mistakes and failures that occur when you're trying new things. And because it's all open, people can see it and talk about it. And our scientists are really open to talking about things that they tried, and now the field has changed, and now you have to change what you were thinking, right? And I want to really flag here that we can include students as knowledge generators. Okay, and so that they can contribute to an ongoing scientific discourse, right? This was just talked about in the past few talks, right? So, what are your biggest barriers to teaching with open with science? And this poll everywhere poll only allows 25 responses, so get them in fast. And now we know how our students feel. This is great. Y'all are really setting me up for the rest of this. So, noticing here this gap between the science that we do and the science that we teach, right? Like, there's complexity in there, and that ends up being much harder for students to use and for us to use sometimes. Navigating data sets, what's available, right? What's possible? How do we use them, right? Right? I need more training. I feel that really hard. Finding compelling and relevant questions, right? I love using an upvote one because I can see that there's more people flagging these top two, right? Expertise in demonstrating data tools, right? Finding relevant open resources. Oh yeah, the 9-month appointment thing. Yeah, I was a 9-month employee for 10 years, yeah. And so when do you have time to design and develop, right? So yeah, great. Thank you for that. So yeah, this is what happens when I ask this question. And if I flip the question and I ask it in a different way, what do you need, or not even what you need, what are your barriers to teaching with any new educational practice? We'll also see the really common things that are also in the literature about that you need time and money. You need a field that's more supportive of you doing new things, right? So that the students aren't rebelling and giving you horrible student evaluations, and your colleagues aren't rebelling and then giving you horrible peer evaluations. Like, you actually need a lot of things to do new stuff. And one that keeps coming up is courage. But specifically for teaching with open science, you also need to find the resources to do it, understand the resources to do it, understand how you teach your students with those resources, right? So our goal really with undergrad ed is to hopefully help support all of that, right? And I've started thinking about educators on this spectrum, and anybody can actually be in multiple parts of this spectrum at any given time, but that there's a lot of folks that are like, well, if you design it, I'll teach it. And then I personally have always lived on the, I'll just design it, thanks, and then I'll figure out how to teach it. But depending upon which class you're teaching, depending upon how burned out you are, you might shift one way or the other, et cetera. And when we've heard from educators, on the left-hand side of this, we hear that folks want plug-and-play resources, okay? Things that they can take and drop into their class. And on the right-hand side, they want support to develop, right, and implement their own materials. And the thing is, left-hand side, plug-and-play resources are actually rarely truly plug-and-play. There's a lot of literature on OERs that we all adapt them for our own uses. And I think this is really just normal. Undergrad ed doesn't have shared learning objectives across all intro classes. You might be teaching things in a different order. You might be teaching things at a different level. Specifically, because I think about neuroscience, I was teaching an intro to neuroscience class to freshmen. And then I have colleagues at other schools that teach that to seniors or juniors. Those are very drastically different classes, and you wouldn't necessarily use the same resources in them, okay? They're also very difficult to design when you're not at an academic institution and you don't have your own students to aim things at or to rapidly test things with, right? And so what I'm really leaning into is supporting, right, the folks that want to be designing and developing And then we will still have plug-and-play resources that are designed by educators that other educators can use as well. And this doesn't mean we won't be creating any resources, but we want to create resources that are specifically geared to being able to design and teach with our open science in a way that makes sense for us as the people working at the Institute. What are the things we can uniquely create? Okay. So we have educator development programs now, right? We piloted last fall Teach Stravaganza, right? So this was a 4-day workshop in the summer. I know Carlos was here, and Ellie, and a number of people, right? This was a cohort of 14 undergrad educators from primarily undergrad institutions. There were 5 facilitators. Omar Quintero Carmona, who I mentioned earlier, developed and led this, right? There's travel, including a hotel and a stipend, right, for doing this. And then this was intended as a low-structure, collaborative, curricular design experience where the whole intention is to set up collaborations between our scientists and educators coming in, okay? There have been some successes that have come out of this. We do have some lessons that have come out of this, some curricular things that are coming out of this, and we also have received feedback about it, right? And some of the feedback is that maybe it needs a little bit more structure, right? Instead of it being a completely open design experience, maybe we need a little bit more structure in there, a little bit more pedagogy, and we really need to be supporting educators over that academic year far more strongly, right? Which is also in the literature as something we need to do. So these are the things we need to provide. This is both from my experience training as an educational developer, it's from the literature, but basically, and this is kind of coming down to some of the things you were saying, right? We need to help folks acquire technological, pedagogical content knowledge, and that's a framework from the ed tech sphere. It's based on an older framework that left out technology, but the technology, especially when we're working with open data and we're working with very large data sets, looks different. And the pedagogy you use to teach coding is different than the pedagogy I would use to teach students about structures of proteins, which is what I used to do, right? And so there needs to be some way for folks to acquire these things, right? And we also need to provide design and implementation support, right? So not just in a space for folks to design with us, but also to help people have a community while they're implementing. And to be honest, we need to be supporting a much broader network of folks and a broader field change to make it easier for people to teach with open science. And so what our approach is moving forward with this, I've already mentioned that we have a scientist-educator collaborative curricular design experience. We're running that again this summer in August. There are some adjustments being made with some extra pedagogy and assessment within it, and a more highly structured community of practice that follows. We've also added a course design workshop that is more pedagogy focused, right? And this one is what I think of as my baby, is specifically for designing neuroscience teaching tools using backwards design. Because neuroscience here has been around for 20 years, we actually have a number of data sets that folks already know about. And so I don't need as much scientific support in the room and can have more pedagogy with it. And so that, to me, right now, it's more open to anybody at any level, but I would love for that to become our early career educator type of workshop, okay? Both of those involve course design, right? And then we're also starting data science skills workshops. This summer, we're offering a coding workshop. I'm co-designing this with Ashley Jovanette, who is upstairs right now, who being the MC for the computational session, and will be leading a coding workshop this afternoon. Yeah, so she and I are putting together a coding workshop. This is not just about, it will include a boot camp for coding as well as people working with multiple lessons that use our data developed by educators and in-house. And also importantly, we're going to talk about the pedagogy of coding and model it as well as have discussions about it in between each coding session. Okay. We're making sure we're offering structured communities of practice. Coding doesn't have one yet, mostly due to bandwidth, and I'm hoping we'll add that next year. So, we also still do like workshops when you go to a conference. Like I'm doing a professional development workshop both at Society for Neuroscience this year and National Institute for Scientific Teaching in 2 months, right? So we're also still providing kind of workshops where people are. And truly maintaining involvement in our broader educational communities. I am on so many committees and so many, like, in so many professional organizations, in part because I've already been on them for years, right? And that has increased some. But also, like, we really want to support this becoming more of a field change, that teaching with open science is more normal. Okay. This is a QR code that will take you to our information on educator workshops if you're interested. There will also be a QR code at the end that just takes you to our education portal. So yeah. I know I have very little time left, so I'm gonna try to speed run resources. So as I mentioned, we're not gonna stop creating resources because that seems ineffectual, to be honest. There's also some stuff that we need to create to make it easier for people to design and teach with our open science, right? And so we're really considering like what would help this educator network when we're designing these things. And then as we're building that network, we're going to be asking, hey, you're designing this thing, what do you need us to create to help you teach that? So the first thing is we're creating what I call the table. So it's a dataset/database table that includes all of our data sets, all of their metadata, the links to the original publications, the links to the GitHub when it exists, the links to any educational resources we already have, and it's aligned with Vision and Change and any other applicable standards in the field. So our Neuro one is aligned with SFN standards, as well as there's a neuroscience concept inventory. Well, I'm working on inventory with some folks, but also like there's a publication in 2023 about the inventory. So we're mapping on that, right? For cell biology, of course, we're using Vision and Change, but I think we're also looking at ASMBM, their standards. For immunology, there's also the work that's coming out of ImmunoReach with their immunology teaching framework and stuff like that. So yeah. Also, right, once you have a data set, how do you know how to use it, right? And sometimes our scientist-facing tutorials, when we have them, are not geared towards undergrads, because they're not supposed to be, right? And so we're working on, when there isn't a data set guide, creating one, and when there is, kind of translating it into something that you could hand to an undergrad or use yourself, right? These data set guides aren't just about, like, they provide background. They also provide kind of step-by-step, how do you work with the tool. They also provide some example, like, research questions people could do and have a student, like, practice with a research question in it. And there's something else for it. But yeah, so they're pretty intensive. The model of these is actually based on something I needed my undergrad learning assistants to create when I taught a cure with our data. So we also are creating explainers and videos, right? So let's say you're planning to teach with our data and you want a pre-reading for your class, and or a pre-video, and you go and you look on YouTube and you look everywhere, there's nothing that's quite right, right? And so we're creating those, right? So that those are available for folks when they are teaching with our stuff, so that there is something that is tailored to what we provide, okay? I'm actually gonna scoot forward just to talk about, these for a second, right? So our most popular one is, what is a UMAP? Which I have found that immunologists really know what a UMAP is, and I did not before I started working here. This is a way of taking multimodal data and collapsing it into like a single or two-dimensional plane so that you can really look at it. So we have, what is a UMAP and how do you work with it? We also have lab tour videos that really we can only uniquely create, right? Where you get to see members of the team that collected all the data talk about it, right? And follow a pipeline through, so yeah. So thank you for your time. I know I left no time for questions, but I am available for all breaks, lunch, and breakfast. This is our education portal. So yeah, thank you.